Welcome back to another M&S tutoring video, and in this video we're going to be working with radicals and complex numbers. We're going to be learning how to simplify radicals, multiply radicals, and as well as adding and subtracting radicals. So let's get started with simplifying radicals. Say for example I have a radical that states the square root of 98, right? Well, how do we simplify this radical? Well, we simplify this radical by finding the factors of the radicand. Well, what is the radicand? Well, the radicand is basically the number inside the square root. It's this number right over here. So we can remember the radicand as the number inside the square root, right? Now, the factor that we find of 98 isn't just a normal factor. We have to find a factor that is a perfect square, and quite for the best reason, the highest possible perfect square that we can find. So we have to find the highest common factor that is also a perfect square. So 98 is divisible by 49, and 49 is the highest perfect square common factor for 98. So instead of square root of 98, we write it as square root of 49 times 2. And if you can tell, this really does make sense because 98 is basically just 49 times 2. And instead of writing it like square root of 49 times 2, we can also write it as square root of 49 times the square root of 2. And since 49 is a perfect square, we can express it as 7 times the square root of 2. And this basically means 7 multiplied by the square root of 2. And in this case, 7 is known as the index. 7 is the index of the radical. And the index, what it basically means is something, although a multiplication sign is not there, it is in multiplication with the square root. And in this case, it's going to be multiplied by the square root of 2. And if we check, we will get the same answer. Let's check it over here. So the square root of 98, when I punch that into my calculator, square root of 98 is approximately 9.99. It's 9.99. Now what 7 times square root of 2 really means is you basically do the square root of 2 first, which is the square root of 2 is 1.442, let's say, and we have to multiply this 1.42 by 7. And when we multiply it by 7, sure enough, we get the same answer as square root of 98, and we get 9.99. And this is also approximate. Right? So now let's look at adding and subtracting radicals. Well, how can we add and subtract radicals? The easiest way to understand this is you have to look at radicals like you're collecting like terms in an equation. Just think of the root itself. So for example, if you have the same thing, if you have 7 times the square root of 2, just look at this root right over here as a variable. So instead of square root of 2, think of it as instead x, and it will make it a lot easier when you're adding and subtracting radicals. So say for example you have 4 times the square root of 5 plus 3 to the square root of 5, right? What you have to think of this as is basically 4x plus 3x, which gives you, of course, 7x, right? But you have to remember that x is actually the square root of 5. So you have to write it as 7 times the square root of 5. And there you go. You just added a radical. Now, what do you do when both of the radicals don't have the same root? Well, say for example you have, instead of both radicals having the square root of -5, say for example you have square root of 28 plus the square root of 63. Well, how do you collect like terms in that? Well, what you have to do is you want to try and simplify the radical as much as you can until both of them have the same root. So 28 is what? 28 is basically the square root of 4, which is the perfect square, times 7. And 63 is basically just the square root of 9. times 7, and 9 is a perfect square. So you can write this as 2 times the square root of 7 plus 3 to the square root of 7. Instead of a 3, it's a 7. So you can write it as 3 to the square root of 7. Notice how when we simplified it, both radicals now have the same root. So we can combine, or we can add both the radicals. And after we add both the radicals, we get an answer of 3 plus 2, which is 5 to the square root of 7. And without a doubt, that is actually the right answer. So now what we're gonna do is I'm gonna give you some scenarios where you can simplify the radical even further. For example, if you have 2 to the square root of let's say 6 over 4, this basically means that it's 2 over 4 times square root of 6 over 4, right? So instead of this, you can write it as 1/2 times square root of 6 over 4, right? Which in return, you can write it as square root of 6 over 2, right? Which makes a lot of sense in return. Now let's talk about complex numbers. What are complex numbers? Complex numbers are numbers involved with I. Complex numbers are usually numbers that involve a square root of a negative number. Say for example, you have the square root of negative 49. Well, what two numbers multiply together? What two of the same numbers multiply together to get a negative number? Well, there's no real numbers that actually do that, because if you want to get a negative number, you have to multiply a positive number and a negative number, right, to get a negative number. But we cannot do that since it has to be a perfect square. So that is where complex numbers get involved. So this is basically the square root of negative 1 times the square root of 49, right? Complex numbers get involved when the square root of negative 1 is written as I. So instead of writing it as the square root of negative 49, which doesn't really exist, we can write it as I and then the square root of 49. And we can simplify that even further to get I times 7. And this is where you treat I just like a variable. So you treat it as just any other variable like x, and you can write it as 7i. Now you have to remember that if you have I squared, you cannot keep it as an I, because we know that the square root of 1 squared is simply just negative 1. So that's where you have to be really careful with I sometimes. Other than that, that's the end of the video, guys. I hope you are more clarified with your basic understanding on radicals and complex numbers. If you have any comments or concerns, please feel free to leave it down in the comments below, and I'll be sure to get back to you as soon as possible. Other than that, thanks for watching, guys.